Good morning or good afternoon, depending on where you are joining me from. Thank you so much for taking the time of your busy schedule to be with me this morning in this webinar. Before I start, I just want to ask a quick question to make sure that you are all hearing me fine. If you are hearing me, please go ahead and raise your hand so that I can see my voice is reaching you. Thank you. Thank you, Charmaine. At least one person raising a hand. I'm going to assume that the rest of you are hearing me fine. Okay, good enough. All right, my name is Hanna. I am the Chairman and CEO of the International Institute for Software Testing. For those of you who do not know me, I see some familiar names who have attended our courses and our webinars before. We have a very large number of people today. We hit our limit of 400 people who registered. Now, we don't know how many are going to join, but again, that's why thank you so much for taking the time to join me in this webinar. Before I start, I want to tell you, as usual, if you have any questions during the webinar, please feel free to click on the questions tab. Not the chat tab, the questions tab on your control panel and write the question. I will be looking at this area while I'm teaching, while I'm talking, and see if there's any question I need to answer. I will also take some time at the end of the webinar to answer as many questions as I can, right? Let's get started. My goal today is that we talk and I discuss with you my approach for how testers can prevent defects. So for all of us as tester professionals, as people who are managing the test process, who are testers who just are starting their test profession, I'd like to show you how we can change our process. We will continue to do the job we were hired for, right? I mean, of course, we always have to find the defects. But also while doing that, I'll show you how we can prevent those defects from happening in the software in the future, so that over time, all the time we spend on writing bug reports and all the time developers spent on fixing those bug reports and all other problems we're going to be talking about can be potentially eliminated. Of course, some of you who probably have just started their career in the tester profession may ask, if I am going to stop writing bug reports, what am I going to be doing then? Well, good question. You will be doing everything you can to prevent defects. So your management will know that you are not just a typical tester, but rather you are someone who's trying to do good for the company, for the project, and doing your job as a true quality assurance. Let's get into the details here. This webinar is being hosted by the International Institute for Software Testing. All webinars from IIST are purely educational. We don't do any sales pitch or anything during the webinars, just in case if you are concerned. Certainly we have courses, we have certifications. IIST is the world leader in software testing professional certifications. You can go to our website and look at the training, look at the courses, look at the certifications. Actually, that reminds me that in about 3 weeks from today, I am doing another free webinar on certifications, software testing and quality certifications. and hope to see you there. I'm trying to remember the title exactly. I think it's Software Testing and Quality Certifications, Facts and Fictions. You can find this webinar, and you can register for it at testinginstitute.com. It's the same website that you used to sign up for this webinar. All right. Here's my agenda today that I'm hoping to cover in 1 hour. It's always, I always jam a lot of information into the 1 hour. Out of the 100 plus courses that are offered by IIST, I teach about roughly 17 or 18 of those. So the ideas that you get today in this free webinar are all picked up from my courses that I teach, because the approach I'm going to teach you is actually my own approach that I developed over the years. So I'm telling you this because kind of warning you that sometimes I might go faster because I need to cover a lot of material. So we're going to start by talking about why we need to do defect prevention. That's an easy discussion because I don't think I need to convince you that we need to prevent the defects. Then we're going to spend some time talking about what defect prevention is, and so we need to understand what that means, and we're going to compare it to defect finding or defect detection. So we're going to talk about prevention versus detection. In this discussion, I need to get into talking about the difference between quality assurance and quality control, or in other words, the difference between quality assurance and testing. So we're going to have that discussion. Then before I get into the methods by which we can prevent defects, I need to talk with you a little bit about the major source of defects that are most expensive to fix, because there are a lot of defects, but I think you would agree that we need only to focus on those ones that are most expensive to test, because if we can prevent those defects, then we are saving more money for the project and organization. Then the last section, which is the bulk of the course here, but the bulk of the webinar, is about how to prevent defects. And I'm going to propose here, just because of the time, I have a full 2-day course on defect preventions. But in this webinar, I selected only 3 of the methods I use to prevent defects. And those are listed there. I don't think I need to read them for you, because if I do, they wouldn't make much sense to you. They will make much sense when I start talking about them. So that is my agenda that I am hoping to cover today. I don't know if that is what you're hoping to learn today. Again, always, please go ahead, share your thoughts, share your ideas, your questions, anything you'd like to tell me. You always click the questions tab, and I will make sure to look at those. All right. With the lack of response back, I'm going to assume that this is okay with you. You're happy with this agenda. All right, let's get started. Why do we need to prevent defects? Now, keep in mind, again, I'm just going to say this one more time for those of you who are kind of new to the software test profession. Your job on a daily basis as you were hired is to find as many defects as possible, and you write bug reports. I'm taking a different angle here on this, and I'm saying you also, while you're doing that, you also need to work in a way such that you can reduce, minimize, and potentially prevent defects. So the big question here is that why do we need to prevent defects? Defects are good, right? Because they keep us employed, because they get us busy writing bug reports. And when we write a lot of bug reports, then we justify our presence, we justify our existence, and our management to think that we are working. Trust me, you will be much happier when you know that you prevented defects from future releases. Okay, why is that? Let me tell you this. If you look in the literature, if you hear about people talking about defect prevention, everyone is focusing on what? On the cost of fixing problems, right? And everyone knows that depending on when you discover the defect and when you write your bug report, at what point in the life cycle, the cost is different. So we all know that, and I'm not saying this, everyone else who have pioneered the software engineering profession said, the earlier you can discover a defect, the cheaper it is going to be to fix. And that's true. Because if a developer discovered a problem while he or she is writing the code, it would be much easier for her or him to go and fix it. Which is very different if we were to discover that defect, or the customer were to discover the defect after the release went out, right? Because then we have to get the issue report from the customer, or whatever you call it. We have to get the ticket from the customer. It has to go through a process. The developer has to analyze it, has to find out where the problem is. And of course, if the problem was in the code, that's easy thing to fix. But if the problem was in something else, like the design, the user interface, the architectural design, in the database design, if the problem was actually misunderstanding of the requirements, or the system works in a way that the customer did not expect, now we are talking about much bigger cost to fix the defect. Honestly, although the cost of fixing defect is there, and many people talked about the cost of poor quality, I am going to focus on defect prevention from a different angle. Look at this diagram. It's a very simple diagram that I use to convince management all the time. If I go to a company to help them improve their test process, that is what I use, and management gets surprised. So this is a very simple process. All of you are familiar with it, right? Development team works, and they write code, they write design, then they send whatever they call it, the build. If you are in an in an agile approach, agile project, then they call it iteration or sprint. Then the test team starts testing. So typically, when you start testing, what do you find? You find some problems, and you write bug reports. The bug reports go back to the development team. They analyze it, they either fix them, or they might come back to you and say, what? They say, works as designed, which means shut up, that's not a bug report, that's not a problem, but rather this is the way it's supposed to work. Or they might find the problem much bigger than could be fixed in this release. They might postpone it to the next release. And the problem remains there, and we put out the software with the existing bug. So that's typical in every project. When they go and fix the problem, they give you back bug fixes. So they give you another build, another iteration, another sprint, whatever you call it in your project. They give you the bug fixes, which you're supposed to retest again. So we call it retesting bug fixes. But I am sure many of you know already, what else? What else do we get with those bug fixes? If you know, quick, go ahead, write it to the questions tab. But I don't think the process, okay, thank you very much. Let me see who's answering this. Martin says other defects. At least I got one answer. Of course. Why other defects? Because it's typical. When people fix the problems, they break the software in other places. Excuse me. Why do they break the software in other places? Because it depends on the experience of the developer who's fixing the bug. I mean, if he is the same developer, if this problem was in the code and the person who's handling the fix is the same person who wrote the code, that might be an easy fix because he or she can go into the specific area in the code and fix it. If the developer is different, if the developer is not does not have a good understanding of the code, if the fix actually or the problem is in the design or somewhere else, then typically, without whether you're willing to accept it or not, there are more defects that we get. I call those regression defects, regression problems. All right. Of course, there are so many questions out there about how much defects do we get with the bug fixes. Again, out there in the literature, whether you talk to Tom McCabe, you talk to Cabers Jones, everyone has his own numbers based on his own experience, right? And I've heard people saying it's 1 to 4, people saying it's 1 to 3, meaning that every time the development team fix one problem, in the average, they create 2 or 3 or 4 other problems. Now, when I say this to developers, they get upset. Some developers get upset, of course. No one wants to accept the fact that they fix a problem, they break the software in 3 or 4 other places. Imagine if you go to the mechanic who fixed your car, and he or she he fixed your car from whatever problem it had, and you go back to him and says, by the way, I brought the car to you to fix my brake, but now when I drive the car, I hear bad noise, the engine stalls, and many other things. I don't think he's going to be happy with that, even if he actually caused all these problems. So when I get the chance to speak with developers, I try to get them to level with me. I tell them, let's just say it's 1-to-1. The ratio is 1-to-1. And I wish I could record all these courses that I taught in person with developers. I have a number of courses on unit testing, integration testing that I teach to development teams. So I tell them, let's just assume it's a 1-to-1, meaning that in the average, and I'm not saying that as a developer, every time you fix a problem, you break the software in one more place. No. Some developers are good, some developers are not good. In some cases, the fix is simple. In some cases, the fix is not that simple. So I say in the average, among all projects, among all bug reports, among all developers, can we agree that in the average, for every bug report or issue being fixed, we break the software in one place, at least one? And let me tell you this, almost all developers agree to that. Because otherwise, if they don't agree, that would mean that they're claiming that they live their life, they fix the problems all the time, they never break the software in any other place, which is unbelievable. You cannot believe that. With my 40 plus years in software engineering, working as a tester, working as a developer, managing test teams and development teams, I know this cannot happen. So there are problems. So let me try to shorten this discussion a bit. So if it is 1-to-1, imagine now, that means that if the test team works for about a week and they produce whatever, 20 bug reports, 30 bug reports, and they send them back to the development team fixes those, send back the bug fixes. So, and they send with them 20 or 30 other problems. I know management gets shocked when they hear that. So that means that there are other problems here that have been created. The bad thing about those problems is this: testers do not know about them, developers do not know about them. It would be nice if a developer comes back and says, here is the bug report you submitted, I fixed it, but by the way, I broke the software in 2 other places, and here are the 2 other places. You understand, this cannot happen. The truth is, developers are not intentionally making those mistakes, are not making them intentionally. So they are there. So because they are there and no one knows about them, guess what? If the test team has a good regression test process, then they will find some of those. And if not, guess what's going to happen? Those fixes are going to go out to the customer, which means features and things in the software that worked before are no longer working. And let me tell you this, based on my experience, nothing at all that would irritate your customer than finding out that things that worked last week are not working anymore. That means that every time they get a new release or a new sprint or a new iteration, things that worked before are not going to work. Would anyone like that? Again, one more time. Would you like to take your car to a mechanic who every time he fixes a problem in your car, he causes another problem? Absolutely not. You would never take the car back to that mechanic. As a result, in my many years of experience, I found out that businesses, customers, over time, they start losing trust. They start losing trust in the IT team, in the company that's developing that's delivering their software. I've been there in both sides over the years. I've been there as a customer, getting software that every time we get a new release, things that worked before are not working. I've been also there as a delivery manager, as a project manager, that every time we put out release, we get new bug reports from the customers that were not there before. So it's a really bad situation. So the problem here is really not only the cost. The problem is that the customer dissatisfaction that happened as a result of this. And again, one more time, when I focus on this for management, they get shocked. That's my only way to get management to moving towards defective prevention. That's how we can understand the value of defective prevention. Okay, let me move on. So we agree that there is a very high cost of fixing defects. In addition, there's also this other area that you cannot put a dollar on it. You cannot assign number of dollars in it. And that is the frustration, the interruption to the business, the interruption to the process when things that worked before are no longer working. Potentially, of course, this will boil down to what? To money. Why? Because the customer will simply say, let's find another vendor. It happened with me several times. It actually was one of the software we used to teach these courses that I'm teaching now. That we got it from a company, a very large company, very known company. And every time we upgraded the software, things started not to work. And obvious things, to the point that I'm about to conduct a course and I cannot see the questions being submitted submitted by attendees. See how bad it can be. All right. To the point I told that company at the time, that was like almost what? Maybe 9-10 years ago, I said, stop it. We're not going to do any upgrades anymore. We're going to live with the old version, all the release we have until what? Until we find another company to replace you. That's the way it would happen. All right. Few things here I want you to know about defective prevention. The first bullet here is very critical because there is a misconception there. There is a misunderstanding. Early detection is not prevention. Because I hear people talking about defective prevention, and all that they're talking about is that we need to do code reviews. We need to do design reviews. We need to do requirement reviews. Well, great. Of course, we need to do this. But let's not fool ourselves. These are not prevention techniques. Because as I said in the second bullet, if you found a defect anytime, early or late, it doesn't matter, then you did not prevent it. So why are you calling it? I have to agree with those people that, of course, if you do a requirement review or design review or code review and find defects and fix them right there, it's going to be much cheaper to fix than letting the problem go back to the customer. It looks like some people have the misunderstanding that if we do something to find defects before the customer finds them, that we're preventing it. Well, that's total misunderstanding. Well, with that being said, then if we test a lot and we find defects during testing, then we're preventing them? No, no, no. All right. We also need to know that if you prevent a defect, then the project does not have to pay for fixing it. It does not exist. And look at what Phil Crosby said. The error that's not made cannot be missed. You're not going to miss a defect or a problem that you didn't make. And at the end, as I told you, defect prevention is the most cost-effective way to deliver software. Now I'm talking too much, but I have not given you anything about how to prevent defects yet. I'm just trying to charge you with the idea that we need to prevent defects. Now, in order for you to understand your role as a test professional and the role of your organization as someone who's managing the test process, I need to discuss with you the difference between quality assurance and the quality control. All right. Some of you may not be familiar with the term quality control. Maybe some people say it's an obsolete term that no one is using. It is true that quality control came from the manufacturing, and I'm sure every one of you, many of you have the word quality assurance either in your title or in the name of your organization. We hear about, QA analysts, QA managers. The department is called the QA. Let me tell you this now. We are all using the term QA, quality assurance, very wrong. Let me explain. Many years ago, I'm going to have to say almost 39 years, when actually I just have come to the United States from my beloved country, Egypt. I had the opportunity to attend a webinar or a presentation by one of the pioneers of software quality assurance, and that is Dr. Edward Deming. I hope some of you know the name. I don't know how I got that, because the presentation, the attendance was very limited. I remember attending this somewhere in Rochester, Minnesota. At the time I lived in Minnesota. So long story short, that presentation by Dr. Edward Deming, I believe that was the last presentation he made before he was gone. That presentation resonated in my mind all these years until now, and I think it will affect the way I do my job and the way I teach people for the rest of my life. And the presentation was mainly, actually, I don't know if you know that or not, Dr. Deming was not a software guy. And I attended the presentation, you know what? Because I've heard that he's very famous. I'm going to go and listen to him. And I knew I'm listening to a guy who's not in software. And I'm a software guy. I had my master's, my PhD in software engineering. At the time, I didn't have my PhD, but I had my first master's degree. So I went there. And what you see on this slide is a summary of what Dr. Deming said in that presentation. Of course, I kind of evolved it over the years, but in many words, he said, when we are focusing on a product, after the product has been completed, manufactured, or whatever, or developed, when we are focusing on this product to find defects on that product, I remember it comes to me the exact word he said in the beginning. He said, "Hi, everyone. How are we doing?" And of course, everyone said what? "Good." And he responds. He says, "No, terrible. You are doing terrible." Of course, everyone is willing to take that from Dr. Edward Deming. And then he explained why he believes that we are doing terrible. because he was talking about that we are going into cycle, finding a problem, fixing the problems, creating more problems, fixing the problems, testing the problems, creating more problems, and the cycle never ends. And I'm very privileged to talk with you today about the teachings of Dr. Edward Deming. So, as long as we are focusing on a product that has been manufactured or developed and completed, to find problems in that product, what we're doing is called the quality control. It's not quality assurance. So when we take a software product that has been built by our developers and we test and test and test and find problems and write bug reports, that's quality control. That's not quality assurance. All right? Now, quality assurance is something we do. In quality assurance is we focusing not on the product, not on the product. We are going back to look at the process that was used to create a product, whatever the process is. And one more time, Dr. Deming was talking about manufacturing, auto manufacturing, electronics, every industry. And again, some of you might already know that the teachings of Dr. Deming is what caused the Industrial Revolution in Japan after he left the United States, because no one listened to him at the time. So he left the US and went to Japan, and the Japanese themselves know that his teachings caused the Industrial Revolution in Japan. All right. And then he came back to the United States and for me just to listen to him. All right. So you focus on the process. Again, one more time. I'm sorry for talking too much, but what can I say? I'm a teacher. I like to emphasize things, but in this discussion, I want you to know, I want you to understand how to prevent defects. All right. My apology. So in quality assurance, we focus on a process that was used to create a product, and we try to find how we can improve that process such that when we use it to create a product, that product does not have as many defects as it's used to have. Very simple. So what does this have to do with testing? We are testers that we were hired to find defects. Well, I'm just telling you this so that in the next discussions, you'll see why I am focusing on the process. I am not going to focus on the products anymore. All right. So based on what I just said, it is my hope, and I tell this to all tester professionals, people who call themselves tester professionals, you must become real, true quality assurance professional at heart. You do your job as a tester, but in everything you do, I want you to think about, have I done something to prevent this defect from happening in future releases? I'm sure some of you are sitting there and saying, well, I don't know if I want to do that. I'm going to tell you this. I was giving this webinar or this seminar as part of a one full day free webinar that I used to give it. Actually, it was at the time it was called seminar because I did it in person. So I used to travel around the country here in the United States and actually Canada to give a full day of training, free of charge. And that discussion was there. Of course, you can imagine. Every time you hear me in a course or speaking, you'll hear me kind of inserting this discussion about about doing defect prevention. And I cannot forget it when a lady stood at the last. I had like 300-400 people at the time, and the lady stood and she said, "If I am going to do this, if I'm going to prevent defects, that means that I'm not going to have to write any bug reports anymore." I said, potentially, that is the hope. And she did not seem to be happy. In fact, she left the seminar after that question. She she was not satisfied, was my answer. I said, yes, absolutely. Absolutely. You need to be converted from being a tester, a defect finder, to become a defect preventer. So she thought by doing that, her job is going to be eliminated, and management is going to say, okay, then we don't need you. That's never true. Imagine when your management knows that you are doing your job anyway to prevent defects that saves the company money. The last word I'm going to say on this, which I say to test professionals here in the United States, I say, you've seen your jobs going somewhere else. You've seen your jobs going to every other country, from China to Egypt to Philippines, everywhere. Companies just decided to offshore things. Right? I'm not against that. I'm not against that because I'm using offshore services myself in my projects. But if we want to protect our jobs, we need to do our jobs in a way that our management know that we are irreplaceable. We are irreplaceable. I want your management to know that they cannot simply replace you by another tester somewhere else who gets $3 an hour or $4 an hour. If all that you do is to test, find defects, and write bug reports and retest the fixes, let me tell you that they can get someone to do this for $3 and $4 and $5 an hour. Do you want that? Do you want to be that person who can be replaced like that? I hope not. So that's my point about this. So please, again, if someone there does not agree with me, have a different opinion, feel free to share this in the questions tab. I am continuously looking at the questions tab here to make sure that, I will share your comments. I will share your opinion with everyone else without mentioning your name if that concerns you. All right, now we need to focus on what are the major sources of defects. However, I am focusing only on defects that are most expensive to fix. There are so many other defects that are easy to fix. That's not what I'm going for. If a developer wrote code and the defect or the bug report that came from the customer or the bug report that was written by a tester was because a developer forgot, instead of putting greater than, put less than. This is a simple coding error that could be fixed in a few minutes. All right. We still do not want to see those, but those are not the kind of defects you can prevent. Why? Because developers are developers. If a developer is not careful and he's going to make those kind of coding mistakes, then he will do them. So if a developer is not careful, he's going to make those kind of mistakes. But again, let's not worry about those. I selected 3 places here, 3 sources of defects. One, if there is code in the system that implements functionality that the testers do not know anything about, of course, testers will not test them. And it will go out to the customer without being tested. Now, I'm sure some of you are surprised. How could there be a code that I'm not aware of? If you have worked with developers, as long as I did, you will see this happens in every system. There is always a gap between the code that's written and the design that's done by developers and the understanding of the system by testing people. So simply, it's a gap between what's being written, what's being tested. Of course, the good news is this: the Agile approach, with all the good things that it brought in, user stories, acceptance criteria. I'm not going to talk about stand-up meetings because some people are fooled by stand-up meetings that we do in Agile projects. And if I talk about the gap, every once in a while, I get someone says, well, if you're doing stand-up meetings, that should not happen. Wrong, wrong, wrong. Stand-up meetings will not discuss anything about this gap. This gap is down there in the details of the code that was written, or the way the design is done, and the way the tester is writing their test cases. So I'm not going to go into details because maybe not all of you are familiar with the concept of stand-up meetings, but I'm going to simply say that do not let those stand-up meetings fool you. I mean, they're useful to a certain extent. Trust me, I would not sit here and tell you things that I have not seen happening throughout my experience. I learned about this gap years ago in 1994 when I was brought into a project to determine if they have done enough testing or not. And that was a larger project. It was a defense project done by a defense contractor. Long story short, when I discovered the gap, I was shocked, management was shocked, and guess what? The project was canceled by the government after the government spent billions of dollars on that project. Thank God the project was not canceled because of my report. The project was canceled because management found out that, and the government found out that, if this system actually goes out, it can cause people to lose their lives, not to protect them. So I'm going to tell you that how serious it is. And of course, it took me years after that. That was in 1994. I remember that. Since then, I started to think about why is the gap? Why did the problem occur? What would they have done to eliminate or prevent that problem from happening? And I found the gap has caused a major problem that about roughly 42% of the code is being released without being tested. Huge gap, right? Huge gap. Testers were not aware of about 42% of what's in the code. So they were testing only 58%. Now, so that's one source. Functionality is not being tested. The other source is this. When customers start using the system, they start doing things that the development team, the test team did not account for, did not think about it. I want you to think about this. Take any bug report that came from the customer and ask yourself, why did the customer find this problem? Why didn't we find it? It's going to be one of these three. It's going to be either that situation, that scenario was there, but we were not aware of it. That's why we did not test it. Or it was not there to start with. So code was never written. Design was never done to handle that scenario. So that's why when the customer tried to do this in the field, it failed because developers didn't even think about it. So you see the difference between the two bullets here, number one, number two. The first one is developers thought about it, they wrote the code, they wrote the design, but testers are not aware of it. This one here, developers did not even think about it, testers did not think about it. We never thought this could possibly happen in production, so there wasn't even code to be handled there, to be written there. And the last one is the one I talked about, bad fixes, which are regression defects. So these are briefly the three sources I'm going to focus on, okay? And let's get into how to do that. Okay, this is a discussion about why there is a gap. I'm going to just go quick on this because I don't want to spend much time. You already know that. I hope I convinced you that there is always a gap between what testers are testing and what developers are writing. If you're not convinced, then you can look at this slide with me very quick. Okay, whether your project is agile or non-agile, it doesn't matter. We get a user story, we get a requirement. The development team starts working. They started discovering problems. There's so many things that happen. I've seen them happening. When developers have a question, they may go back and ask the product owner. They ask the business analyst who wrote the requirement. They get an answer. They go back to their cubicle. They start fixing the code or writing the code or adjusting the code to reflect the answers they got for their questions. The problem is the test team is totally outside that loop. Okay, I have not seen it happening very often. Of course, one more time, if someone is going to bring the stand-up meetings are not there for that gap at all. They don't discuss that gap. So I will just do with that without this slide, assuming that you believe me that there is a gap. And the gap is happening because developers are working in one way, testers are working in a different way. And that is what I learned from that project I'm telling you about. Developers make assumptions all the time. I mean, you can't stop them from doing that. Developers read the requirement or read the user story. There are so many things they don't know. We all make assumptions. We all make assumptions about things, even in our daily lives. So please, I want you to adopt this rule in your life. Any assumption you make about anything at all remains invalid until you validate it. Do not make a decision. Do not take a position based on an assumption you made about anything, about anyone, before you validate your assumption. That's a rule of thumb. You can assume things, but you must be aware you are assuming things. And then you must be aware that you need to validate those assumptions. Developers do not validate their assumptions. I do not want to generalize here, but many developers make assumptions. They write their code, they write their design based on the false assumptions. They don't know that they are false. And as a result, the testers do not know about it. So now in this approach, I'm going to focus on closing the gap between development and testing, because the gap seems to be the most critical thing here. Here are my ways to close the gap. Now someone says, hey, you are coming back to talk about requirements and user story reviews. Didn't you say that those are not defect preventions? My method? I did. But remember, I'm talking about collaborative, ongoing requirement and user story reviews. I'm talking about collaborative, ongoing code and design reviews. The purpose here is not to find defects. Keep that in mind. Because remember, when you do code reviews and design reviews, I ask people all the time. I said, what are you trying to do in a code review? I ask actually testers in one of my courses. I ask a tester, says, if you have been invited or have been asked to attend a code or design review, what do you do there? In many cases, I don't get an answer. In other cases, they tell me that because we need to find the problems in the code. I always say, who are you to think you're going to find problems in the design or the code? Who are you? Are you saying that developers are not capable of doing that? So from my point of view, code and design reviews, requirement reviews and user story reviews are not mainly to find defects. It's the same thing I've talked about testing. I want you to prevent defects while you're testing. So when you do code and design reviews, when you do collaborative requirement reviews, when you do scenarios validations, the purpose here is to close the gap, is to make sure that we are all on the same page. When we review requirements, I want to make sure that testers and developers, product owners, and business analysts, we are all on the same page. We have the same level of understanding of the requirement. Not because I want to find problems with in the requirement. Because if I just find problems with the requirements, then I'm not doing defective prevention, because the problem is there. If I wait until the code and the design is written and I do code or design reviews, and all what I'm focusing on is to find problems in the code or design, then I'm not preventing anything. So that's why I tell tester professionals, you are there in a code or design review meeting so that you can close the gap, so you can understand what developers are saying and compare this to your own understanding of how the system is supposed to work, and make sure you know everything. So this is closing the gap between what's in the code and the design and what's in testing. This is closing the gap in the requirement understanding. Scenario-based development and testing, which I'm going to give you a quick glimpse at it here. This is simply to help us make sure that we know how the system is supposed to behave the same way that the product owner and the business analyst and everyone else knows it. So as a result, you'll see that scenario-based development and testing will actually eliminate the problem of code coverage. I mean, code coverage is very important. I know I did not speak about it, but the problem with the project I was telling you about, if code coverage is very low, 58%, that means that that's all what we're testing. And the remaining is not being tested. Okay, I came up with the daily or weekly update meetings to kind of supplement the stand-up meetings in Agile projects, because I found out that stand-up meetings do not really address the gap. In the stand-up meetings, if you're not familiar with them in an Agile project, all what we do is to talk about what we did yesterday. We talk about what we are going to do today. We discuss problems that we encountered yesterday. We discuss problems that we anticipate to happen today. We try to avoid problems so that our day goes smooth and we can produce what we're supposed to produce. No one at all, and please correct me if you think I am wrong, no one at all gets into the details about the difference in the code and the difference between the code and the testing. This is a low-level discussion that does not happen there. So as a result, I added this daily or weekly update meetings, which none of those meetings, by the way, none of those meetings have to be actual physical meetings. In fact, I have another webinar that talks about collaborative online reviews, which does not suggest any meetings, because you can imagine over the years how many of those meetings I have attended, how many of those meetings I held, and how many times I found that they completely fail because people do not like meetings. People come to meetings without being prepared. People try to just come to the meeting because they have to, and so on. So that's a different subject that I'm going to try to schedule that webinar sometime. I've done it, I think, about 3 years ago. This webinar that I'm holding now, by the way, I've done it like almost a year and a half ago. But over this last year and a half, I added more things I thought I needed to talk about. That's why we scheduled it also for this week. So these are the things I'm going to talk about. If you have more questions about these, please send me an email. My email is mhanna, MHANNA @testinginstitute.com. Scenario-based development and testing. Of course, if I have a full 1-hour webinar on scenario-based development and testing, I actually did them about a month ago. So you can go to the website at testinginstitute.com and listen to that webinar recorded. All our webinars are being recorded. They are posted on the Testing Institute website. So feel free to go there to learn much more details about scenario-based development and testing. But I'm going to show you this quick picture here. So typically you start either with a requirement or a user story. If your project is agile or non-agile, you may have use cases, which I'm not going to discuss what they are here. You may have any one of the models, such as user interface models. These are the starting points here. So what I'm proposing here is that we spend enough time to do the collaborative analysis and reviews online. That's all online, by the way. I'm not suggesting any meeting here. And then while we're doing this, then we start building our scenario collaboratively. Again, all the details about building scenarios are in that webinar. And of course, I have a 3-day course where I cover this process in all details. And then we do the scenario validation. It's very simple. You know, in the early days, in about late 90s, when I developed this process, I used to call it what? I used to call it the common sense process. The common sense process. And I used to tell people, take that process, explain it to your management, see if they agree with you or not. Very simple. And then once we collaboratively validate scenarios, we go down. Those scenarios will go to the design, to the test, to the development team for them to do the design and the coding. The same scenarios would go to the test team to do their test design. Just this simple diagram. I know. Again, one more time, when I did this, so I looked at the picture more than once. Every time I look at it, it says, this is common sense. If people are not doing the software like that, how else are they doing it? This process is out there intentionally, believe it or not. When I was submitting patents, I have 21 patents out there. When I was submitting patents, I did not submit this one because I intentionally said, I want this to be available for people to use all the time. So this is not patented. Feel free to take a picture of that slide elaborate on it, discuss it with your management, whoever you want to discuss with. All right. So why is this simple picture almost a silver bullet? It is, because it covers the gap in every way possible. From the very beginning here, when we start collaboratively reviewing the user stories or the requirements or the user interface, we close a lot of gaps here about between that, because this discussion, of course, you know, that is going to be between testers, developers, product owner, business analysts, everyone. It's going to be continuous also. It's not a meeting today that we hold it for an hour or two and we're done. No way. That's not the way it's going to happen. It's an ongoing online using a tool. You can use whatever tool. I'm using a tool called Romana, the tool from our sister company, Romana Software. You could use Jira. I'm sure Jira will allow you to do that. You could use whatever you want. When you start building scenarios collaboratively and validating them, you close even more gaps. The bottom line is, by the time we reach here, everyone is on the same page. There is no way for developers to write code or do design that's not being tested by the test team. There is no way. In fact, in Romana ALM, I even have a report where you can easily put your hand on a scenario and get all the code that was written for that scenario, and also get all the test cases that were written for that scenario. So bottom line is, once the code is written, we know for sure every block of code that was written is being tested by testers. Sorry. Why? Because the code and the design, as well as test cases, are all based on what? Scenarios. And scenarios are very concrete, very specific. So this is, in my opinion, unless someone else contradicts me, is the most effective way for closing the gap. Right. I'm beyond my time here. This is just a simple picture of the asynchronous collaborative reviews, meaning that we're not doing it at the same time. Simply we could do overtime. So we started the review, and throughout the project it's there. And the last one I want to talk about is impact analysis. Remember I talked about bad fixes? My apology. I'm going to go back very quick here. You remember those bad fixes? I am suggesting that we use impact analysis to make sure that when developers fix the problem, they know exactly where else they affected the design and the code. Impact analysis is a big discussion. My sincere apology. I don't have another webinar to talk about impact analysis. This would have been the only webinar. I'm going to give you the simple analogy here. So I'm simply telling the mechanic that I take my car to fix. I'm telling him, please, after you fix what you're supposed to fix in my car, go around and see if you screwed up anywhere else. If you are replacing my brake pads, please make sure you tighten the wheels very much, because I don't want to take the car and drive on the road and then the wheels that fly on the air and I'm gone. If you're replacing something in my car, go around and inspect your own work. Make sure that you did not break the system anywhere else. The main purpose of impact analysis is to avoid those additional bugs that we got. I have so much to say about impact analysis. I'm going to run to that last slide here quick. And I have made good experience with it. And maybe I should just do 1 hour webinar on impact analysis and how it should be done, because I found this to be very effective in avoiding those additional bugs we get. Here is my conclusion. Always strive to prevent defects. You will always release software with some defects there, but eventually you will prevent them all. Rework will always cost more than doing it right the first time. And we know that already. That rework is always likely to introduce more problems. And of course, if you find a defect, then you did not prevent it. The last bullet simply saying that don't be fooled when people tell you that we're going to do code reviews, design reviews to prevent the problems. I have a last question here. Do you suggest the development team use tools to check code to make sure they did not break anything else? There is no tools that tells developers they broke the system anywhere else. It's always manual and intellectual process. There are tools to help the developers find out programming mistakes like undefined variables, loops that are not being executed, whatever. This is kind of syntactic problems, but there is no tool that I'm aware of that, and I don't see even a way to implement to develop such a tool to tell people there's minor things that says, okay, if you made a change to this table, then remember here are the places where this table is being used, for example. Okay, changes to database tables are the most critical things. So, and I've used this method, it's simple search. If I change it, if I made changes to one of the tables, I can search my code for all places that uses this table and make sure that the changes I made do not affect everything else. So in a way, yes, the tool is as simple as a simple search to search about the specific thing you change it to see where else it's being changed. Thanks for the question, though. Right, no further questions. I am closing the webinar. Thank you again for being with me for this 1 hour and 4 minutes.